When we start to move towards metallic minerals, and some of the minerals that we're looking for resources, they can be much, much heavier. So we've got things like iron minerals. This is just a straightforward piece of kidney ore, which is hematite. This has a density of between 4 and 5 grams per cubic centimetre, which means it starts to stand out. So in places like Australia, where they have very large banded iron formations, they really do stand out on gravity surveys quite nicely. We also have things like garnet, which makes up quite a large amount of the deeper parts of the Earth's crust. This is a nice, pretty garnet from Tanzania, and it's shaped like a football or a sort of dodecahedron. And this actually makes up a lot of the crust, and it has a density of about 3 to 3.5. So it's volumetrically quite large, and we tend to find some quite interesting ore deposits associated with garnets. As we move in towards the heavier realm, we can get to something really heavy. Let me find something that's really heavy. So this is pretty dark. I don't know if you can see it. There we go, if I shine a light on it. This is a tungsten ore. It's called ferberite, so it has a bit of tungsten and a bit of iron mixed in it. This I can tell you is quite heavy. It weighs well over a kilo. It's maybe 2, maybe 3, maybe even 4 pounds, and it's not really very big. So compared to some of the other pieces we had, like the coal, which weighs maybe just a few hundred grams, this is getting on towards 10, even nearly 20 times as heavy. So it's really quite substantially different, and that gives us a fantastic contrast to be able to image deposits that contain tungsten if there's enough tungsten involved in the situation. But one of the most important minerals we look for are something called sulfides, and so I'll finish this section with a sulfide.